In this lecture, we are going to discuss about Taylor series for two variables. So in this module, we are going to discuss Taylor series formula and need for a Taylor series and its geometrical interpretation, and finally end up with one problem. So what is Taylor series formula? Here I have provided the Taylor series formula here. F of x comma y equal to f of a comma b plus 1 by 1 factorial fx of a comma b x minus a plus fy of a comma b y minus b plus 1 by 2 factorial fxx of a comma b x minus a the whole square plus fxy of a comma b into x minus a into y minus b plus fyy of a comma b into y minus b the whole square. Similarly, this can be extended for the third terms. So here the formula given for this series is expanded about the point a comma b. So before entering into the problem, let me know why do we need of a Taylor series. In more often, real world problems involves complex functions like multiple variables such as x, y, z, and these can be approximated by simple polynomial expressions from the Taylor series. Taylor series revolves the information about how functions behave at the point, such as the function can be approximated a nearing point. Even we can get the information about trends, that is increasing or decreasing of function, oscillating natures, and many other things. Even the Taylor series can be used to solve the differential equations and many more. Now we consider the Taylor series expansion for the exponential function e power x equal to 1 plus x square by 2 plus x cube by 6 plus x power 4 by 24 plus x power 5 by 120. Now we have a graphical notion to check whether this Taylor series expansion is correlating with this curve or not. So first of all, already we know what is the curve for e power x. This is the curve which was presented here, e power x. This is the e power x curve. Now what we are going to do is, just I'm going to check the expressions given before is equal to this. So yeah, so if you see the before slide, the expression for e power x is 1 plus x x square by 2, like this. So let me see what it graphically means. Here the curve e power x, if I take the first term in the a series, which is x equal to 1, that is 1. So this is a curve for x equal to 1. So it is the first term of the series. If I include the second term, then the curve which is a second term, that is x, which is the equation is 1 plus x. Now the curves looks like this. Now if you compare these two curves, e power x and in this 1 power x, it looks much forward. So I'm going to add one more term in this series, that is 1 plus third term also, that is x square by 2. If I include this term x square plus 2, now this vertical lines become little bit curvy. Now this part of e power x and this part of the series expansions appear to be same. So I'm going, just what I'm going to do is I'm going to add the fourth term of this series. Now the curves exactly with little bit of much better than the previous appearance. So now this curve represents little bit closer than to this e power x. What happen if I include one more term? So I'm going to add this one more term. So now more probably this in the positive quadrant, the curve which are going to approximated is getting closer to e power x. So what happens if I add one more term, this now this curves e power x and the curve for the series approximately approaching the as possible as equal. So what can we conclude from this? So if you are more adding one more terms on this, the for the e power x, the curve is going to get closer to the actual curves. So that from this what can we conclude? Taylor series is series which is able to approximate the functions in case of it is not explicitly known. So now look at one problem for a Taylor series. Find the Taylor series expansions for up to second degree for the function f of x comma y equal to x square plus xy plus y square above the point 1 comma 1. So what we are going to do here? So first of all, we provide a formula for this. And function here is explicitly given, f of x comma y equal to x square plus xy plus y square, and we are supposed to expand the Taylor series above the point 1 comma 1. So we proceed with the problem. So we proceed with solution first of all. So this is a formula for Taylor series which was already discussed. F of x comma y equal to f of a comma b. Here the a represents 1 and b represents 1. So I am pretend to expand this Taylor series above the point 1 comma 1. Therefore what I prefer to this, here a equal to 1 and b equal to 1. And the function which I prefer to expand is f of x comma y. So f of x comma y here is x square plus xy plus y square. So what are the things I need is, so I need to find fx of a comma b, which is nothing but dou f by dou x, dou f by dou x. Yeah, yes. What is fy of a comma b, which is nothing but dou f by dou y. Just I am going to differentiate this given function partially with respect to y. Similarly, what is dou fxx, which is nothing but dou square f by dou x square. What is dou fxy, which is nothing but dou square f by dou x into dou y. Similarly, what is dou fyy, which is dou square f by dou y square. Here they asked for second order, so I'm going to find this first term, second term, and this third term only. If I suppose they've asked for a third order, now I may include this third term also. So first what I'm going to do is I'm going to find what are the things needed for this. Here in the first term is f of a comma b. What is f of a comma b? Yeah, here they have given a function f of x comma y. So what does it means? Just I'm going to replace a equal to 1 and b equal to 1. That is, I'm going to replace x equal to 1 and y equal to 1. So what is the value for this? The value for this is 1 square plus 1 into 1 plus y square, which is equal to 3. Therefore which is my f of a comma b. So what next? I'm going to compute the second term of this series, which is fx of a comma b. What is fx? Differentiate these equations with respect to x, which is 2x plus y. Now again differentiate this equation with respect to y, therefore x plus 2y. Now substitute the points x equal to 1 and y equal to 1 in these two equations. I supposed to get fx of a comma b, and this is fy of a comma b. So what I'm going to do is I'm going to calculate the next term, which is fxx of a comma b and fyy of a comma b. Other than this, fxy of a comma b. So what is fxx? Differentiate partially dou f by dou x with respect to x again, which is equal to 2. What is fyy? I'm going to differentiate fy with respect to y again, so which is equal to 2. What is xy? This, and what is the thing is I'm going to differentiate fy with respect to x. So the value I will supposed to get is 1. What I'm going to do, I want to substitute x equal to 1 and y equal to 1 in this equation. But fortunately here I don't have a terms x and y here. Therefore fxx of a comma b, that is 1 comma 1 is same as f of x's. So fyy of a comma b is as same as fyy. Fxy of a comma b is as same as fxy. So that is, so these are the required values I have calculated. Now I'm going to substitute in this equation f of a comma b plus fx of a comma b is nothing but Yeah, previously we had find it what x minus a, here x minus a here is 1 plus fy of a comma b into y minus b here is 1, therefore I have substituted here, plus 1 by 2 factorial, 2 factorial is nothing but 2 fxx of 1 comma 1, that is fxx of 1 comma 1 I have found it here, then plus 2 fxy of a comma b, fx of a comma y is here I have found out here, into x minus a into y minus b, that what here is. Just I am going to plug in the values what which I have found out earlier. So just if I have found it, f of 1 comma 1 is 3, I have to plug in here, fx of 1 comma 1 is 3, I have plug in here, into x minus 1 into 3 into y minus 1 plus 1 by 2. Now substitute fxx of 1 comma 1 which is 2, I have substituted here, put the x minus 1 as it is, plus 2 into fxy of 1 comma 1, fxy of 1 comma 1 is 1, therefore put it as it is. In I am having x minus 1 into y minus 1, so as it is. On simplifying all these terms, I get this f of x comma y approximately equal to 3 plus 3 into x minus y plus 3 into y minus 1 plus x minus 1 the whole square plus x minus 1 into y minus 1 plus y minus 1 the whole square. Actually, what these terms, as discussed previously, instead of having the curve which was given earlierly, this set of all curves will approximately give an approximation for the actual given functions. So in this lecture I have a quick review on this what we have discussed in the lectures. We have discussed about Taylor series, need of a Taylor series, and we discussion of Taylor series formula, and we had a graphical meaning regarding the Taylor series. These are the things we have discussed in the in this lectures, in this lectures. In next lectures we have another topic and discuss about furthermore. Thank you.